Good afternoon to everyone. So today topic is solution of global warming, right? So the global climate change is certainly one of the top environmental issues nowadays, right? So the global warming is a dangerous effect on our environment, right? So that we are facing these days, all of you know about that. So increase in the population growth and pollution and rapid industrialization. So those are causing a rise in this global warming. So global warming refers to increase in the average temperature of the Earth's surface during the last century. So the global warming is a gradual process that is heating and rising temperatures in the Earth surface and atmosphere, including oceans and also ice caps, right? So what are the causes? So, these are many causes of global warming. Some are natural and some are man-made causes, right? So I already told about these man-made and natural causes in your previous class, okay? So the most important cause of global warming is greenhouse gases, right? Greenhouse gases. So which are generated from naturally and with human activities. So these are increased. These are increased because of the increase in population and also economy. So the release of carbon dioxide and chlorofluorocarbons and harmful gases in the atmosphere, which leads to rising our temperatures, right? So the global warming has been accelerated due to mass deforestation activities by humans. So the burning of fossil fuels. So remember this word, burning of fossil fuel. So that is using lots of vehicles and cutting down trees, etc., etc., right? So these are the main causes behind this global warming, right? So another major cause of global warming is depletion of ozone layer, right? So the ozone layer causes protection to the Earth's surface, inhibiting the harmful sun rays that is coming to the Earth, right? So it is depleting due to excess release of chlorofluorocarbon gas and global warming. So that harmful ultraviolet sun rays enter into the biosphere. So that is causing more temperature and global warming. So these are many causes of global warming. That warming is a danger for the existence of life on the Earth, right? So the most evident causes of global warming are industrialization and deforestation and sophisticated human activities, right? So these human activities have led to an increase in emission of the greenhouse gases and resulting of this the temperature increasing and the melting of glaciers, right? So in fact, so you see the average temperature of our planet, it has increased by how much? 0.8 degree Celsius or 33.4 Fahrenheit. So that is compared to the end of the 90th century only. So each of the last 3 decades, it has been warmer than all previous decades since the beginning of the statistical survey in the year of 1850, right? So at the pace of current carbon dioxide emissions, some scientists expect an increase of between how much this year? 1.5 degrees centigrade and 5.3 degree centigrade or Celsius. So that is 34.7 degrees to 41.5 degree Fahrenheit. So in average temperature by the year of 2100. So if no action is taken, what will happen? It would have harmful consequences to humanity in the biosphere also, right? So when the heat trapping greenhouse gases are increasing, and what is happening? So it is automatically global temperatures. Global temperature is rising and earth is warming and the glaciers are melting and also the sea level is rising, right? Sea level is rising. So this weather change is drastically affecting wildlife and forests, right? So is it correct or not? Yes. So the global warming is happening due to the greenhouse effect. So some of the contributing factors are burning of fossil fuels, deforestation, and also livestock production and industrialization. So the burning of fossil fuels such as natural gas, oil, coal, and gasoline. So these are raises the level of carbon dioxide, right, in the atmosphere. So, and carbon dioxide is a major contributor to the greenhouse effect and also global warming. And consequently, it leads to drought and incessant rainfall, hurricanes, and extreme heat waves, and also other extreme weather conditions, right? So with these adverse effects of global warming happening across the world or across the planet, so we need to implement ways to stop global warming and protect our planet, right? So now you see here the consequences of global warming. So consequently, it leads to temperature on Earth increases and heat waves and droughts and sea level rises due to melting ice sheets and glaciers and also climate change and changes in precipitation pattern and emission of greenhouse gases and habitat deforestation of animal in Arctic regions and coral bleaching and crop failures and food security gets affected and environmental migration, floods, storms, air pollution, and loss of biodiversity and wildlife and hurricanes, tornadoes, risk of human health, desertification, loss of fresh water cycle and cyclones and higher death rates and pest invasions and water shortages and wildfires, stress on ecosystem and gross domestic products loss, that is called GDP, and distribution disruptions in production of energy and damage on property and infrastructure. So here are some simple actions you can take to help reduce global warming. Here you see now. So first one is recycle more. Recycle more. So the aim is to cut down the amount of carbon dioxide released into the environment. So if you recycle half of the waste produced at your home, you can save up to how much? 2,000 pounds. 2,000 pounds means 1 ton. 1 ton of carbon dioxide every year. So you save 1 ton of carbon dioxide. That is every year. So next, driveless. Driveless. It means air pollution is one of the major factors that lead to an increase in greenhouse gases and minimize the use of cars and make use of public transportation, right? So they try to walking, biking. So these are the great forms of exercise or carpooling whenever possible, right? So even vacations can provide opportunities to reduce your carbon footprint also. So if you reduce the driving hours, you will end up saving how much? 1 pound. 1 pound means 454 grams of carbon dioxide per every mile, not every year. This is every mile. Okay. So now we're going to switch to renewable energy. So one of the most effective ways to prevent global warming is to start using renewable energy sources. So those are solar and geothermal and also wind and biomass, right? And stop using fossil fuels. So use only renewable energy resources to supply power to your home or your office, etc., 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 right? So now you can use only renewable energy resources, okay? Next, use energy efficient devices only. So by investing in energy efficient devices such as bulbs, LED lights, or solar power shower systems, and you can reduce the energy consumption and it helps in the production of clean energy. So it is only not only the cheapest way to reduce greenhouse gas emissions, but it also reduces the amount of carbon dioxide released in the atmosphere, right? So avoid some products that come with excess packaging, especially molded plastic and packaging. So that can't be recycled, right? So that is the main reason. So if you reduce your household garbage by 10%, you can save how much? 1,200 pounds of carbon dioxide annually, right? Now we are going to use less hot water. So it means, do you know, you can save 500 pounds means 50 grams. 50 grams of carbon dioxide per year if you switch to cold showers, right? And stop using hot water to wash your clothes. And try installing energy efficient geysers so that consumes less energy, right? And next we are going to turn off your electronic devices. So ensure turning off your electronic devices such as TV, a computer, and also some of the stereos and music players, so etc., etc. So those are when not in use, right? So you can switch off your electronic devices. So this can help in saving fuel that is used to generate electricity, which in ton, it can reduce 1,000 tons. How much? 1,000 tons of carbon dioxide released in the atmosphere. So save electricity and reduce global warming by turning off lights when you leave your home and using only as much light as you need, right? And remember to turn off your television and video player and stereos and also computers when you are not using them, right? So remember these words. The next, spread awareness. So spread awareness, it is also speaking, right? It means speaking. So speak up about global warming and its consequences and causes and what steps we can take to prevent about global warming with your friends or families, neighbors or colleagues, etc. Right? So use the power of social media to voice your concerns about climate change. Okay. Then next, save water. This is also very, very important thing, right? So make sure to turn off taps while brushing and go for shorter showers and do not waste water by cleaning your cars or bikes, right? So by following these easy steps, all of us can play a significant role in reducing carbon dioxide emission and preventing global warming. So thus preserving the planet for future generations. So it's also a good idea to turn off the water, right? So when you are not using it. So while brushing your teeth, shampooing the dogs or washing your car and turn off the water until you actually need it for rinsing, right? So you will reduce your water bill also and it helps to conserve a vital resource, right? So now, so one child. So it means more humans, more greenhouse gas emissions. More humans means more greenhouse gas emissions, right? Next, plant trees. So this is also very important. Plant trees. So the deforestation, it means deforestation plays an important role in global warming and climate changes, right? So the planting trees is helpful as they absorb carbon dioxide, right? Carbon dioxide. And from the atmosphere, right? And regulate the climate. So hence, there is a dire need to plant more trees because a single tree, so a single tree can absorb 1 ton. How much? 1 ton. 1 ton of carbon dioxide in its lifetime. Okay. So trees can be a quick solution to combat climate change, but each year we destroyed how many trees are forests? 30 million acres of forests, destroying the biodiversity of these amazing ecosystem, right? So we can buy recycled paper and use it several times. We can buy only certified wood and we can plant more new trees, right? So plant a tree, start digging, and during photosynthesis, trees and other plants absorb carbon dioxide and give off, what is that? Oxygen, right? So these are some of the solutions for global warming, right? So just wait. Now, so now we are going to layers, means so layers of the atmosphere. So now the atmosphere has 5 primary layers, right? So before going into main topic, we start from the Earth. Right? So the Earth is the third planet, right? Third planet from the Sun. Is it correct or not? You see here. You see here. Okay. So you see here. So this is the 1, 2, 3, third planet, right? So third planet from the, which one? The Sun. Sun. So the distance from the Sun is how much? 149. 149 million and 600,000 kilometers. 149. So 149 6,000 kilometers. So remember, the distance from the Earth to the Sun is called an astronomical. What is that? Astronomical units. AU, that is called AU. So 149,600,000 kilometers, it means 1 astronomical unit, right? So astronomical unit means the distance from the Earth, right? Distance from the Earth to Sun. So that is called astronomical unit, AU. So which is used to measure distances throughout the our solar system. Right? So the Earth is the only planet that is known to have an atmosphere and containing free oxygen, oceans of liquid water on its surface, and of course life roughly how much, that is 70, right? 70% of the Earth's surface is covered by water, right? So in most of it in the oceans, and remaining 30% of Earth's surface is land. Okay, 70% is water and 30% is land. So now let's understand the layers of the atmosphere. So the atmosphere layers an important role in making life possible on the Earth by protecting our Earth from harmful ultraviolet radiations of the sun. So the atmosphere of Earth is the layer of gases, commonly known as air, right? Air. So that sounds the planet of Earth and it is retained by Earth's gravity. So the figure shows how temperature changes here. You see here in this how the temperature changes with height in our atmosphere. Temperature profile is represented with this red line, right? So the x-axis is temperature, right? So in degrees Celsius, every 20 degrees, right? Every 20 degrees. You see here this one. So from minus 100 degrees to plus 20 degrees. These are the minus and these are the plus. So, and y-axis is height in kilometers, right? Height in kilometers. And the increment is how much? 20 kilometers, as you can see here, right? So the first layer of the atmosphere is, what is that? Troposphere, right? Troposphere, this troposphere here. So almost all weather, so that is of importance for us, takes place in the troposphere, storms and also clouds, hurricanes, precipitation. So these are, that is the all in the troposphere, right? So in troposphere, temperature decreases linearly with height. That is linearly means straight line, right? Straight line up to here. You see here this one, right? So the average temperature around the globe at the sea level is how much? 15 degrees Celsius. 15 degrees Celsius. So the troposphere is about how much? 11 kilometers high, and the temperature at those altitude is minus 56. How much? Minus 56 degrees Celsius. So in this layer, the temperature decreases. Temperatures are decreases with the height because atmosphere is predominantly heated by the surface, right? So further, we are from the surface, the colder, right? So it gets the top of the troposphere is called, what is that? Tropopause. This tropopause you see here. Right? So now the troposphere is how much? 11 kilometers, right? 11 kilometers deep, but that is not everywhere around the world, right? The depth of the troposphere is around how much? 9 kilometers in the polar regions. Remember this word, 9 kilometers in the polar regions and the 17 kilometers in the tropical regions. 9 is polar regions and 17 is tropical regions. So this has to do with the fact that pressure decreases faster in cold air than in warmer air, right? So you will remember that we said, let's assume these are two pressure surfaces. They are further apart if the air between them. So that is warm. Then where if the air between them is cold, and that's why this troposphere is deeper in tropics. That is then it is in the polar regions. Okay. So and then the next layer is the stratosphere. stratosphere. And this layer is between approximately 11 kilometers. Right? So here, the first stop, we learn about temperature variations of the layers, right? So what you observe here in this temperature, this red line, right? This red line temperature varies of the layers. So this temperature on one axis on the base and altitude, right? So what we see with the altitude, what happens to the temperature? So you look at this particular place, it is troposphere, right? It is troposphere. So what happens? The temperature actually goes from positive. So this is positive and this is negative. So from here, positive to negative. Okay, it is going from positive to negative. So till this particular transition zone, that is called tropopause, right? This tropopause. So the ball itself, it pause here. There is a mixing zone where there is a pause happening. So what happens from this pause again? Again, these temperatures, it has starts to rise in stratosphere, right? So now for some time, it remains constant. So now you see here, this one, up to from 10 to from something 20 or 30, right? So remains constant and then again starts rising when we go ahead in what? In attitude in stratosphere, right? So that is important. Then what we observe again is, again, it remains constant here. Now again here, constant and here also, right? So for some times, so which is this stratopause, right? Stratopause, this stratopause. And then again, it starts decreasing the mesosphere up to here, right? So that is negative minus degrees Celsius at the upper boundary of this mesosphere, right? So it goes to the minus segment, right? So, and this is the plus segment and this is minus segment, right? So then in mesosphere, what happens? The mesopause. This mesopause is the transition zone between mesosphere and thermosphere. Okay. So again here, sometimes it remains constant also here. Okay. So it is how much? 2 degrees Celsius. And then again, it goes on increasing 82 degrees Celsius to 1200 or above, right? And further, when we go to the exosphere, right? So we find the differences. So what we see is this diagram. So it is a like sigma, right? Sigma kind of situation. So this symbol, right? This one. So sigma kind of situation in the diagram, if you observe this one, right? So this is the simple diagram. If you can remember, this looks like sigma symbol, right? From the troposphere, to the exosphere, the outer sphere. That is the outer sphere. So how does this isotherm look like this line? That is sigma. So which we say. So this looks like a sigma, right? So what happens here? There is a change in temperature across all these 5 layers with attitudinal factor. So that is where the structuralization of the atmosphere is important, right? So on the basis of this temperature, so that is where we say those 5 layers structures are the stratified structure of the atmosphere, right? So now you look into the layers of atmosphere. There are 5 layers of the atmosphere above the earth. So that are separated by temperatures. So each layer are separated by an increasing or decreasing temperature of the gases in the layer. So now you look into these layers are, first one is troposphere. This is one. And second one is stratosphere. This is 2. And third one is mesosphere. This is 3rd. And fourth one is thermosphere. And last one is exosphere. That is 5th one. Okay. So these 5 layers are important in the atmosphere. So now look into one by one. So troposphere. First one is troposphere. Tropo means, it means change, right? Change. So it is the first layer of the atmosphere. So you see here this one, troposphere. This is the first layer of the atmosphere from the earth, right? From the earth. So it is also the one where we are living, right? So we are living in troposphere only. So this layer gets its name from the weather that is constantly changing and mixing of the gases. So in this part of our atmosphere, so this layer is the lowest and closest to the earth surface, right? So an average, the troposphere extends from the ground to about how many kilometers? You see here 12 kilometers, right? 12 kilometers are 7.5 miles above the sea level. Above the sea level. Okay. So the air never starts in this layer. So it means in this layer, there is a lots of changes. So tropo means change, right? So in this troposphere, there is a lots of changes happening. So that's why it is also called changing sphere. What's that? Changing sphere. So troposphere is a dynamic sphere. Is a dynamic sphere. So where lots of changes are happening, right? So that's why it's called changing sphere. So in this layer, where lots of atmospheric phenomena, it keeps happening in this sphere, right? So all weather condition changes, it occurs in this particular layer. So most of the clouds you see here, So these are the clouds, right? So these clouds. So most of the clouds appear in the troposphere mainly because what is the reason? Because of 99%, 99%, sorry, 99% of the water vapor in the atmosphere is found in this troposphere. So that is the main reason. So that's why the clouds are appears in this troposphere only. So the troposphere contains about 75% of all of the air in the atmosphere and almost all of these water vapor which forms clouds and rain that we should understand, all of you know. So in this layer, the air is made up of approximately how much you see here? 78% of nitrogen and 21% of oxygen and 1% of other gases. So, and that is including argons and water vapors and carbon dioxide, right? So nitrogen, oxygen and other gases. So totally 100%, right? So, and apart from that we observe here, what is happening? So the temperatures decreases as you see in this graph, right? So the remember the temperatures decrease at the rate of 1 degree. How much? 1 degree. 1 degree Celsius for every 165 meters. Right? So, and so many people also write it into that is 6.5 degrees Celsius per 1000 meters. Right? So, you can write 1 degree Celsius for every 165 meters, or you can write 6.5 degrees Celsius per 1000 meters. So that is for 1 kilometer, right? So it is an average value. So you can take either of them, okay? So that is, right? So that is also known as, what is that? Lapse rate. It's called lapse rate. L-A-P-S-E, lapse rate. L-A-P-S-E, lapse rate. Okay, lapse rate. Right? So now remember there is a temperature decrease with the increasing altitude in troposphere. And this is also called the normal lapse rate or environmental lapse rate. That is ELR. It's called ELR, environmental lapse rate. So this is the first layer of the atmosphere, that is troposphere. Okay. Then next we are going to another sphere, stratosphere. This is the second layer of the atmosphere. Okay. So stratosphere, strato means it is layer. Strat means layer. So this layer of our atmosphere has its own set of layers. So the boundary between the stratosphere and the troposphere is called the tropopause. So it is the region where aeroplanes are flying. So because this less turbulent layer, it provides a smoother ride. So the jet streams flows near the border between the troposphere and the stratospheres, right? Tropopause. So the lower boundary of the stratosphere is called tropopause, right? This is tropopause. So upper boundary of the stratosphere is called stratopause. Right? So that stratosphere layer extends from the tropopause. It is about how many kilometers? 50 kilometers. That is 31 miles. 31 miles above the earth surface. Above the earth surface. So this layer contains a thin layer of ozone molecules which forms a protective layer and absorbs harmful radiation from the sun. So you see here, this layer is a very dry as it contains little water vapor. It means the water vapor content is less here, right? So the stratosphere actually gets warmer the higher the trends of rising temperatures with altitude. That means air in the stratosphere lacks the turbulence. What is the reason? Lacks the turbulence and updrafts of the troposphere beneath. So the high altitude weather balloons are flying into the stratosphere. You see here some of the balloons here for monitoring atmospheric conditions and climate research. So the air is roughly 1,000 times thinner at the top of the stratosphere than it is at sea level only because of this, right? So the commercial passengers jets fly and weather balloons also reach their maximum operational altitudes within the stratosphere only. So this layer provides some advantages for flights, right? So why? Because there is an advantage to fly in this layer because the stormy weather is not there. What is the reason? Stormy weather is not there. So the stormy weather actually ends at the only the tropopause only, right? So above this tropopause, there is this layer where there is an advantage of flying for the flights, right? So the ozone layer is found in this layer only. So that absorb ultraviolet rays and safeguards it from harmful radiations. So the lower stratospheric as ozonosphere. What is that? Ozonosphere. And what is the altitude of this ozonosphere? It varies from 15 to 35 kilometers. How much? 15 to 35. So from tropopause to the upper stratosphere, this is 15 to 35 kilometers, the variation, right? So we can say it is majority the lower portion of the stratosphere where this ozone concentration is there, right? So the infamous ozone layer is found within the stratosphere only. Where is this ozone layer in this figure? Here, right? So in the atmosphere, ozone exists in two forms. So that is good ozone and bad ozone. So all of you know about this good ozone and bad ozone. So bad ozone means bad ozone formed in the atmosphere that harms plants and animals. And good ozone, so good ozone means, so that is the protects us against dangerous ultraviolet lights from the sun, right? So good ozone is found in the upper part of the atmosphere, that is stratosphere. And it acts as a shield absorbing ultraviolet radiation from the sun. So these ultraviolet rays are highly injurious to living organisms since DNA and proteins of living organisms. So those are preferentially absorb ultraviolet rays, and its high energy breaks the chemical bonds within these molecules only, right? So the thickness of this ozone in a column of air from the ground to the top of the atmosphere. So it is measured in terms of DU. It means Dobson units. Dobson units. Okay. So this is the stratosphere. So this is the second layer of the atmosphere. Now we are going to third layer of the atmosphere. It's called mesosphere. Mesosphere. Right? So now meso. What is the meso? It means middle. Meso means middle. Okay. So this layer is located above the stratosphere and the below the thermosphere, right? So you see above the stratosphere and below the thermosphere. So middle of the mesosphere. Middle. So this is the mesosphere, right? So it is the coolest layer of the entire atmosphere. So what is the reason? So I will tell. So it is the third layer in our atmosphere, right? So, and its variation is from how much? 50 kilometers. 50 kilometers to 85 kilometers. Okay. Totally 53 miles above our planet or above our Earth. So by the 80 kilometers, it reaches up to about minus 90 degrees Celsius. How much? Minus 90 degree Celsius temperature. So about 80 kilometers, it becomes now minus, right? So that is important. So that's why this layer is called coldest layer. What is the reason? So minus degrees temperatures is there. So that is very important. So that's why so this layer is called as coldest layer. So the air in the mesosphere, it is far too thin to breathe of air pressure at the bottom of the layer is well below how much? 1% of this at sea level and continues dropping as we go higher. Right? So now you see here, most of the meteors fall and burn up in this atmospheric layer. So the transition boundary which separates the mesosphere from the stratosphere is called, what is that? What is that? Stratopause, right? So in the mesosphere, fewer air molecules to absorb incoming electronic magnetic radiation from the sun. Right? So then next. So now next layer is the thermosphere, right? So sorry for the inconvenience. So thermo means, what is the thermo? Thermo. It means heat, right? Heat. So this layer, has extremely high temperatures and located above the mesosphere and exosphere. So that is called thermosphere. Okay. So the boundary between the mesosphere and the thermosphere, atmospheric region, so that is called, what is that? Mesopause. You see here, this mesopause. Mesopause. So it is the coldest parts of the Earth's atmosphere. So the thermosphere extends from the mesopause to how much? 700 kilometers. It means 440 miles. 440 miles from above the surface of the Earth only. Surface of the Earth. So the thermosphere is the thickest layer in the atmosphere. So only the lightest gases and also mostly oxygen, helium, and hydrogen. So these are found in this layer, right? So the thermosphere absorbs high energy X-rays and ultraviolet radiations from the sun, and the atoms turning them into ions with positive charges, right? So the temperature of the thermosphere varies between night and day and between the seasons as do the number of ions and electrons which are present. Right? So the ionosphere reflects and absorbs radio waves, allowing us to receive shorter waves radio broadcast from the other parts of the world, right? So the temperatures in the upper thermosphere, it can range from about 500, how much? 500 degrees Celsius, that is 932 degrees Fahrenheit to 2000 degrees Celsius or 3632 degrees Fahrenheit, right? So now you see here the radio waves which are transmitted from the Earth are reflected back by this layer, right? So the thermosphere has another further bifurcation where we say this is called the ionosphere. Here, okay? Okay, so it has electrically charged particles ionized by cosmic and solar radiation. Okay. So the ionosphere ions are there. The charged particles are plus and minus, right? So these I already told about the plus and minus. So basically, these charged particles are the important factors which are called ionosphere in the lower thermosphere, right? So which actually lead to this radio wave transmissions. So that is helps us, and where this charged particles, the ionosphere, reflects back and it leads to radio wave communication. It helps us in the, right? So the temperature increases with height, going to height, right? So the aurora and satellites mostly occur in this layers. You see aurora and satellites. So you see here also aurora and these satellites. Okay. So aurora means, this means an aurora is a natural light, right? So natural light display in the sky. So particularly in the high latitude regions only. So that is caused by the collision of energetic charged particles with atoms in the high altitude atmosphere. So this is where these charged particles are ionization happens, and that is where the flash of radiations in different kinds of color streams, right? And also these satellites for communications have been placed in this layer, so that we see here, right? So that is the important. So now we are going to exosphere, right? So this is the last sphere of the atmosphere layers. So exo means outside. It means outside. Okay. Outside. So that is called, it is the outermost of the layer, right? So the exosphere represents the outermost layer of the Earth atmosphere. So it extends from the top of the thermosphere at an altitude of about how much? 700 kilometers, right? From thermosphere, not only at, okay, or sea level. So about from thermosphere 700 kilometers, and above the sea levels to about 10,000 kilometers. It means 6,200 miles or 33 million feet. So where it merges into the solar wind above the Earth's surface. So this layer is mainly So this layer is mainly composed of extremely low densities of hydrogen, helium, and several heavier molecules, including nitrogen, oxygen, and carbon dioxide, closer to the exobase, right? Exo base or base. So in this layer, the ozone where atoms and molecules escapes into the space that is mentioned as the exosphere, right? You see here, this is the space. So the International Space Station orbit is also in exosphere only, right? Now we are going to catalytic ozone creation and destruction. So how ozone is formation and how it destruction. So now you see here. So when we say the natural ozone cycle, and what happens is there, so this O2 which is given oxygen, right? And it reacts with the ultraviolet light. So that is ultraviolet radiation. It breaks into the oxygen plus oxygen. So that is separated O, right? That is separated O and separated O. It means O2 plus ultraviolet radiation breaks O plus oxygen plus oxygen, separate oxygen plus separate oxygen. So now this one separate oxygen, this separate oxygen plus attaches itself to the oxygen O2, right? And it becomes, what is that? O3. O2 plus O equal to O3, which is what we commonly called as ozone, right? So that's where this ultraviolet is important here only, right? So O3 plus, again, this O3. So O3 plus ultraviolet radiation. Again, it gives you one oxygen plus one O2, right? So this is a simple chemical equation. So O3 plus ultraviolet, it gives O plus O2, right? So the ozone in the stratosphere is continuously being made and broken by the ultraviolet light in the ozone oxygen cycle. So this is the natural ozone cycle. Okay. So after introduction of chlorofluorocarbons, you see here, then if the chlorofluorocarbons are there, then we see these ozone holes happening here, right? So why? Because remember, the chlorofluorocarbons react with ultraviolet and it forms different byproducts, that is chlorofluorocarbons and independent charged particles, that is ions species in chlorine and others, right? So the chlorofluorocarbons plus ultraviolet gives, it gives chlorine plus chlorofluorocarbons and also others, right? So what we see is this chlorine, now this chlorine plus O3 means ozone. It gives, now we see different kinds of molecules formations, right? ClO plus and O2. So what happens? This ozone is actually broken by this particular chlorofluorocarbons, right? So the chlorofluorocarbons break this ozone. What we see? C plus O3 equal to ClO plus O2. So in this particular equation. So what happens when the ozone is broken? It means ozone's concentrations is now being destructed, right? So the formation and depletion are both important factors, right? So if ozone is being destroyed, what will happen? So this ultraviolet factor, which is used to be neutralized here, right? So this ultraviolet factor, which was earlier neutralized by ozone, is now actually coming to the ground. And that where ultraviolet radiation is harmful for human beings and animal lives as well on the Earth surface. So this is the whole idea of ozone depletion and ozone sustenance or destruction, right? So this is the natural ozone cycle. And after the introduction of chlorofluorocarbons, these are the equations and natural cycles. O2 plus, this here O2 plus ultraviolet, we mixing up ultraviolet. So now you can easily understand So first one is, what is that? So O2, which is oxygen, right? So, and it react with, what is that? Ultraviolet light. So it gives, or it breaks into O, single O plus single O, right? Or separate O plus separate O. And then next, so this separate O, so attaches itself, what is that? O2, oxygen, O2. And it becomes O3. It gives O3. O plus O2 equal O3. So which is commonly known as ozone. This is ozone. Right? So then next, so now this O3, again this O3 plus ultraviolet radiations, it gives O plus O2. Okay? O plus O2. So this is the simple chemical equation, right? Now, after introductions of chlorofluorocarbons, now you see here, so the chlorofluorocarbons, it's coming chlorofluorocarbons plus with react with ultraviolet rays, right? Ultraviolet rays. It gives, what is that? Different byproducts. So that is what is that? Ultraviolet rays. It means chlorine. Chlorine plus chlorofluorocarbons. These are the byproducts. Then next, so this chlorine, right? So this chlorine react with O3, ozone. So it gives ClO plus O2. ClO. So one is going and remaining O2. So ClO plus O2, right? So then next, this ClO react with only single oxygen. It's called chlorine plus O2. Chlorine plus O2. So this is the simple chemical equations. This now natural ozone cycle and after introduction of chlorofluorocarbons, right? So this is very important. Okay. So now this class is over. So I can stop here. So I will take the next class after some time.